It's only her. It's only her. Hi, it's only her.
Hello, everyone.
Yo, what's my name?
You are asking me? You tell me what is my name. Can you tell me what is my name? In full name. Why did you tell him? I
know already. I know already.
Really?
Yeah.
Okay, I'll ask you later. Another day. My full name.
Bendo.
Surprisingly, I know most of my students' name. I mean, at least I know all of your first name, at least.
I was my last name.
But when I ask other what is my name, they have no idea what is my name. Like after having an entire semester together, they don't know what is my name. Like how disappointing that is. And they expect to get A in my class. Like, really?
No, I know your name, so I should get A. I know your name.
No, what I'm saying is this. You don't care about me at all.
I care
at all. So why do you think I should care about you?
Yo, I think about your class.
That's my point, okay?
Yo, I think about you, my state.
That's too much.
Wait, can I get A? I think about her. No, you can't be saying it. Why?
Oh man. I wasn't feeling well. You have no idea what is so funny. I think I'm getting sick. All of my family members are sick. So
we're mad. You want to get sick?
Not cough, like you just told me care about.
Huh?
You just told me care about me, and now you're contradicting yourself.
So very one-sided.
Exactly.
You can't hear. Oh shit, that's my bottom.
Okay, so good news, you have only 2 sections to cover, and then our syllabus will be over. Bad news, these 2 sections are a little bit longer. Okay, so I'm planning to make it as shorter as possible, but giving you all the information.
So after we're done with these 2 sections, we're done
with the syllabus. So our next exam will be December 4th, which is Thursday.
Is it like
and then
on, like all the material?
Based on after the derivative.
Oh.
So 2.7, 2.3, 2.4.
Gonna be the hard.
Right, this is the thing, and 2.10. I didn't give you 2.10 question in this exam, right? No, related right now. So 2.7, 2.10, 2.3, and 4. 4 sections.
So that's gonna be the hardest.
One of the hardest, that's true. And I'll try to post a review sheet over the weekend. So next week we have class only Tuesday, and then Thursday, Friday we have off, and then we are going to meet again next Tuesday, and then your exam will be on Thursday. The exam will be based on whatever we cover before the exam, okay? So whatever we cannot cover, that will not be in this exam. Okay?
You're gonna straight take the final one, or is it somebody else?
No, final exam is made by the department.
Oh shit.
So this section talks about limits and continuity. And for limits, either it's one of the easiest topic or it's one of the hardest topic. Okay? Unlike derivative is always the easiest in calculus.
What?
But the limit, derivative is the easiest, trust me. If you take harder level classes like calculus 1, 2, 3, what's wrong with my throat? Then you'll see in the entire calculus world, derivative is the easiest one, easiest topic. Come on. I have water and I have cough drop. I just laughed so much that. Okay, so We are talking about limits. When you talk about, guys, when you talk about limits, we talk about y value, okay? So what is the limit? The limit of a function is a value that the function's output, which is a y value, approaches as we observe the input, which is the x value. This concept is fundamental to calculus and describe the function's behavior around a point instead of the point itself. What does that mean? It means, let's say a function, something like this. And let's say we have an x value here. And we have a y value here. Now, limit means we want to see at this point what is happening to the function. Sometimes the function gets, sometimes the function is continuous, so we get a valid y value. Sometimes the function is not continuous, so we get invalid number. For example, if you have a hole here instead of a circle, instead of a closed circle, if you have a hole, the y value doesn't exist for this x value a. Even though the y value doesn't exist, we want to know if the y value existed, then what that number would have been, okay? That's the limit. So what we do, we observe the y values from the left side. When you walk to your function from the left side, what y value you're getting, and when you walk from your right side of this function toward this number, what y value you get. So you look at the left side and you get the right side. If both sides gives you the same number, means if both sides have the same y value, then we say limit exists, and the limit at that point is the same number as what we got from the left side and what we got from the right side. How do you write this out? Is this format. Limit x as x goes to a of this function is the y value L, so it's a y value, okay? And different people use different letters for that. Here, L means limit, it's the y value. It's the number. So you observe the neighborhood of your function that is closer to the x value here. Like for each x value, what's the y value we get closer and closer and closer to the number you're observing from both left and the right side. That's the limit. So why do you care about the limit? Why do you work with them? What's the point? The main reason we work with the limit is that math has a black hole scenario. Means we don't get the y value always. Like the example I just showed you. We don't get the y value, a valid y value. We have a hole in our function, or we may have a break in our function, or we may have vertical asymptote in our function. Like we have so many problems in our function. So for those problems, we don't know the y value. Even though we don't know the y value, we want to know the y value because that will help us to determine the total behavior of the function or the total characteristic of the function. Okay, that's why we care about the limit. For example, let's say we have a line 2x plus y, 2x plus 4. And we want to know what's the limit when you're going toward the x value 1 of this function, what's the y value is supposed to get. So if you take, so this is 1, this is 0, and this is 2. So what we do is we look at all the numbers very close to 1. So 0.0009, 0.009 is here. When you have 0.9, our y value is kind of like, let's say this is 5, and let's say this is 7, and this is 6. For this y value here, for this x value here, 0.009, 0.999, your y value is closer to the 6. If you get another point that is closer to 1, something here, you get a y value that is even closer to the 6. So all these numbers, they are on the left side of 1, and that tells us our y value is getting closer to 6, 5.998, 5.99998. They're getting closer and closer and closer to 6 from the left side. So you go to the right side, and you take one number, 1.001, somewhere here. For this number, we see our y value is 6.002. So it's closer to 6. Then we can observe another number that is even closer to 1 from the right side. So let's say somewhere here, 0.0001. For this x value, we get the y value here. So if you observe these 4 numbers, toward which number they all are approaching? 6. So we say our limit for this function, when x is going toward the toward 1, the y value is getting toward the number 6. So the limit here is 6. Okay. But doing all this math takes time. And realistically, we don't have time, right? So instead of doing this table method, we are going to learn how can we find this limit without using this table. That's the purpose behind section 2.3. Find your limit, means the y value. What's the y value we are getting towards to when you go to a specific x value? If you look at the graph is here. When x is 1, look at the y value, it's straight 6. So f of 1 is 6, but it may not exist for every function. So that's why we look at all the numbers from the right side and all the numbers from the left side, and we compare them. If both sides go toward the same y value, then that is our limit. That's the y value we're supposed to have at that place, at that position. Okay. So bottom line, the y value represent, the limit represent a y value in a function. For example, we have another function, x squared minus 4 divided by x minus 2. Now, what happens when you go to 2? When x is 2, what happens here? 2 squared minus 4 divided by 2 minus 2. So we have 4 minus 4 divided by 0, which is 0 divided by 0. What is 0 divided by 0? Undefined. It doesn't exist. So the y value doesn't exist when x is 2. But we cannot stop here. We want to know, well, we know y value doesn't exist, but if it did exist, what that number would have been. So what we do, we apply the limit. This is a graph of this function. We go, so our y value, x value is 2 here. We want to know, even though the y value doesn't exist, but what the y value should be. So we take a look on the left side. If you pick a number very close to that 2 on the, if you pick an x value close to 2, what y value we get? Here. If you pick another number close to the x value 2, it gives a heart. Wow. So for some reason, my mouse loves these concepts. Interesting. If you pick another y value, another x value close to the x value 2, the y value we get is here. If you pick another number very close to 2 on the left side, the y value is going toward this number. So all these numbers are here. If you're approaching the x value 2 on the left side and substituting all those numbers here, the y values are getting toward 3.9, 3.99, 3.999. So what y value they're going toward to? Y equals which number? 4. But when exactly at 2, the y value doesn't exist. So now we are observing the right side. When you go from the right side of this function, what's the y value we get? So we pick an X value that is closer to the 2 from the right side. When you substitute into the function, you get, this is the Y value we have. We can pick another Y value closer, very, very, very close to 2. And we see the Y value we get from here is here. So these are the numbers we get if you walk from the right side, closer and closer and closer to the Y value, closer and closer and closer to the X value, the more you're moving from the right side. What's the Y value we are getting here? 4.001, 4.01, 4.1. So what's the Y value? 4. That means even though we don't have the Y value exactly at 2, but if you did have a Y value at 2, that Y value must have been 4. Okay? So this is 2 examples where one of them, in the first example, we do have a Y value and our limit is same as the Y value. In this example, we don't have a Y value, but the limit tells us what the Y value should have been if it existed. Okay, clear? Now let's do some scenario. Weird scenario. Let's say we have a function like this. It's called piecewise function. It's a piecewise function. What is a piecewise function? It's 2 or many different pieces of functions together into one plane. So in this function, for every number smaller than 0, our Y value is 0. For every number bigger than 0, our Y value is 1. And when X is 0, our Y value is 1. So for every number smaller than 0, our Y value is 0. When X is 0, our Y value is 1. And for every number bigger than 1, our Y value is 1. So every number bigger than 0, every X value bigger than 0, our Y value is 1. So in this type of function, we want to know what's the limit at 0. X equals 0. What's the limit at X equals 0? So observe the left side limit. If you walk towards 0 from your left side, what's the Y value we have? 0. If you walk towards 0 from the right side, what's the Y value we get? 1. So is the left side limit and the right side limit are the same number? No. That tells us at this point, the limit doesn't exist. Which no matter what you do, you're not going to make this function continuous. It's completely discontinuous. On the other hand, this function is continuous. It just has a hole. So we can fill this hole with Y value 4, and this will become the entire continuous function. But here, there's no way you can fill a hole and make this continuous. It's completely uncontinuous function. We call it discontinuous function. So there are some scenario, limit doesn't exist, and you have scenarios, limit do exist. In order for the limit to be existed, we have to have left side limit and right side limit same number. If you don't have the same number, then the limit doesn't exist. And if the limit doesn't exist, it means it's completely discontinuous function. Okay. Now that tells us about one-sided limit, means what the limit you get if you walk from the left side or if you walk from the right side. So how do you denote them? We denote them using this symbol. Limit X is going towards some value with a minus sign. It means going from the left side of your number A. So limit X is going toward A from the left side of this function. This is what it means. That's how we write the limit of f of x as x approaches from the left side. And if you want to indicate the right side, you write limit as x goes to A with an arrow and then a plus symbol on the subscript. So not superscript. So it means you are walking toward A is any number from the right side, and this means you're walking toward A from your left side. And all these numbers are actually Y values. We are walking toward the X values, but we are observing the Y values, how Y is changing. Now, in order for a limit to exist, the left side limit and right side limit, they have to be the same number. In general, if you have a jump, like this scenario, the limit doesn't exist. If you have a hole, the limit doesn't exist, but we can make this limit to exist if you make your function as a piecewise function. You can say our function is this, when y value, when x value is that number, is not that number, and then our y value is this, when x is that number. For example, the first question, y equals x squared minus 2 divided by x minus 2, right? So minus 4. We know when x equals 2, this function doesn't exist. So this function exists when x is not 2. So we can make this function continuous by saying when x is not 2, this is our y value. And when our x is 2, our y value is 4. So what happens? We have a function like this, and this part is telling us fill out your gap with y value 4. So see, that hole was discontinuous, but we filled that hole, now it becomes a continuous function. That's why if you have a hole in your function, we call them removable discontinuity. Means we can remove that hole. But when you have a jump, it's called non-removable discontinuity. Means there is no way we can remove this discontinuous function into remove that discontinuity and make it into a continuous function. Okay. For example, that scenario, there is no way we can make this function continuous. You can make it a continuous, but it won't be a function anymore. We could make it continuous if you fill out this part, but if you do that, it fails to be a function. In order to be a function, you have to pass the vertical line test. So you fail the vertical line test if you do that. So you cannot make this discontinuous function into continuous function. However, we can make this discontinuous into a continuous function. Now let's do some example about one-sided limit. Sorry about this. We have a discontinuous function. And in one point, we have a jump. In another point, we have a hole. This hole is removable. This jump is non-removable. Means we cannot remove that. Now, the first question is asking, we are going to 2 x value 2 from the left side. So let's go to this x value 2 from the left side. For 2, if you want to work on the left side, which part of the function you have to work on? This piece is on the left side of 2, right? So you have to work on this function. So if you work on this function and you're going toward the x value 2, what is the y value we are getting? 3. So this is our answer here is 3. When you walk to 2 from the left side, what's the y value we get in this function? So the left side has this piece. When you walk, we get the y value 3 here. The next part is asking, go to 2 from the right side. So which piece is on the right side of the 2? The bottom side. So if you walk on the bottom side here, what is the y value we have? 1. Remember, limit is y value. So you are going toward an x value, but you are working on your function. So what's the y value of this function? Or you go to x value to 2 from the right side. So when you work from the left, it's 3. When you work from the right, it's 1. So this one is asking when you're exactly at 2 what is the limit? Good job. You guys already understood the concept. It doesn't exist because the left limit is telling us, hey, it's 3, but the right limit is telling us, hey, it's 1. We have two different numbers. So exactly at 2, we cannot have anything. The limit doesn't exist. In order for limit to exist, the left and the right, they have to give us the same number. Then the limit exists. Okay? Now try 5. They're saying limit is this. They're saying, hey, go to 5, which is here. Class, go to 5 on the left side. So this is 5. This is our y value here. If you walk from the left side, this is your left piece, right? So walk from the left side. So this is exactly at 5. Walk from the left side. What's the y value? 2. Now they're saying, hey, walk from the right side. So this is our 5. What's the right side? Here. If you walk from your right toward this number, we still get 2. The last one is asking, then exactly at 5, what is your limit?
2.
2, because the left side is giving you 2, the right side is giving you 2. So the limit exactly at 5 is 2. But there is another question. What is f of 5? Means when x is 5, what is your y value?
1.
1. When x is 5, we have a closed circle here. That's a valid y value. Here we have a hole. So there is no valid y value. We have a valid y value at 1. So here the answer is 1. So what is telling us? It's telling us the limit at 5 is 2, means both sides of the function is going toward the y value 2. However, at 2, the y value doesn't exist because the y value is at 5 when you're at 5. So the y value is 1 when you're at 5. So is this function a continuous function? Is this a continuous function here? No. The limit and y value are different, so they cannot be continuous. So in order to be a continuous function, we have 3 conditions. The left limit, right limit have to be the same number. Also, those 2 numbers have to be the same as the y value at that point. Okay? So if the y value was 2, we have a continuous function. So in order to be continuous, the left should be equals to the right, should be equals to the y value. So 3 things have to be same if you want a continuous function. In order to have a continuous function, the left side limit, the right side limit, and the y value, all 3 things have to be the same number. Okay? If the left side limit is not same as right side limit, the limit doesn't exist, so it's automatically discontinuous function. And it's unremovable discontinuous function. If the left side limit and the right side limit are same, and the y value are the same, then it's a continuous function. But if the y value is not same as the left and right limit, it's a discontinuous function, but it's a removable discontinuous function. Why? Because we can simply put this number and put it here, it will become continuous.
What is continuous?
Continuous means you can draw a function without lifting your pen. If you ever can draw a function without lifting your pen, it's a continuous function. Can you draw this function without lifting your pen? No. From here to here is continuous, but then you have to lift and then start from here again. So here too is continuous. And then you don't have two. So here, continuous here, or you cannot repeat also. You don't have to, a function is continuous if you can draw it without lifting and without repeating yourself. So here it's continuous until here. But if you make the whole from this side, if you want to go that side, you have to repeat yourself. So it's not continuous. So you cannot repeat your direction and you cannot lift your pen. If you can draw a graph with that two condition, then it's a continuous function. Okay. So continuity and limit, they go hand in hand. The limit tells us whether it's a continuous function or not. So limit rules means what type of rules we have. They are saying, well, these are too bad. But the main idea, let me tell you, if the limit exists for two functions, then the limit of the sum is sum of the limit. It means you can distribute the limit to functions and take their individual limit, add them. For subtraction, you can do the same thing. You can take the individual limit and subtract the limits. Multiplication is same, division is same, constant multiplication is same. Like limit is commutative. You can always move them around. Also, if you have a power, you can move the limit inside the power, take the limit of the function, and then you can apply the power. Limit of a constant is always the constant itself. Limit of the y equals x line is the limit itself. So y equals x is a line this. So if you're finding the limit at this point, this is your y value. If you're finding the limit at this point, this is your y value. It means your x and y value are the same number. Blah, 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 blah. The rest are not so important. What is important is how you're going to find the limit without using the graph. So usually when you have a function as an equation, all you have to do is substitute the limiting value. Oh, whatever we have here is called a limiting value. Let me write this down. Limiting value. Whatever we have here is called limiting value. So in order to find the limit of a function from an equation, all you have to do is substitute that limiting value into a function. When you do that, then you get different types of scenarios. Based on the scenarios, you use different approach to get the limit. Usually the limit is easy. When you substitute, if you get a number, your life is fine. You just stop, that's your limit. But if you don't get a valid number, let's say you get a number over 0. A number on the top, but the denominator is 0. This is undefined, right? It doesn't exist. Or let's say you got 0 over 0, like the situation we did before. This is also undefined. So after you substitute the limiting value into the function, if you bump into this type of situation, then you cannot go any further until you modify your function. So you have to rearrange your function so that when you substitute the limiting value again, it doesn't give you this type of problem. So how do you modify? Most likely you can be able to factor, cancel. If it's not factorable, not cancelable, then you have to use conjugate. You multiply top and bottom the conjugate so that it becomes smaller. Or if you're working with trigonometric function, then you have to use trig identity to modify that. Once you modify your function, then resubstitute, and this time is supposed to get a good number. If you still don't get a good number, that means the limit doesn't exist, or you made a mistake somewhere. So go back and check. Okay, that's all the main outline. So this picture is very too blurry, but here it says for every situation what is supposed to do. I'm gonna post this notes okay, so that we can see that. Once you substitute, if you get a real number, stop, that's your limit. Once you substitute, if you have a number over 0, that means you have a problem. What type of problem? We have vertical asymptote. What does it mean? It means our graph broke into two pieces to complete continuous pieces. So we are going to factor, cancel, whatever possible we're going to do, and then we're going to resubstitute the limiting value. If you have a 0 over 0, sorry. If you have particle asymptote, so particle asymptote, the limit will be either positive infinity, negative infinity, or doesn't exist. These are the three choices for particle asymptote problem. So we are going to take a number very close to the limiting value on the left side and see what type of number we have, positive or negative. We are going to substitute another number very close to the right side and see what type of number we have, positive or negative. If you have the same sign, the limit is positive infinity. No, so if you have same sign, the limit is that infinity, positive or negative. But if you have two different signs, then the limit doesn't exist. Or particle asymptote. But if you have a scenario 0 over 0, that means you have to do factoring, conjugate, or trigger integers to modify and then resubstitute. And rest of the class or rest of the section 2.3 and 2.4, not 2.4 actually, 2.4 have more details. In 2.3, that's what we are going to do. Depending on which situation we are in, we are going to apply different methods to approach. Clear? So all you have to do is remember this. What type of approach we have to do when you bump into these specific types of problem. So let's start. It's not hard, it's just, you just need more practice. And lots of memorization. Remembering things. First scenario. We are substituting our limiting value into the function and we get a number of a number. If you have this, your life is easy. All you have to do is stop and box your number, box your answer. Because that's your limit. Since this is too easy, this will not be in the exam. And not in the final exam. This is too easy, right? So here it says, take your limiting value and substitute into every x you see in your function. So we get 5 times x cubed minus 3 times x squared plus x minus 6. Your limiting value is 3, so substituting every x with 3. And then we get 5 times, what is 2, 3 cubed? 27 minus, this should be 27 because 3 cubed. And then we have 3 and 6, gives us negative 6. Negative 3, yeah. Thank you. And this is a real number, right? Whatever that number is. It's a real number, so we stop and we box our answer. What's the number? Do you know? Can you calculate someone? 135? Oh, the final answer. 5 times 27. 105? So it's a real number. As long as you have a real number, you're happy because that's the limit. We don't have to do anything.
Also, the real number is
Real number is acceptable.
so that's the answer.
105.
Or 105.
105 is your limit.
So we got.
And we accept that because it's a real number. Real number, so stop.
We have to write as the limit of 5.
Just box it.
So we have box it and like real number.
You don't have to write the real number. I'm writing it so that you can understand.
Oh.
How about the next one?
What is it?
Our limiting value is 0. So every x you see in your function,
That's 0.
so we get 4 times 0, 5 times 0, plus 3, 0 minus 7 times 0, plus 14. So 0, 0, 0, 0, we left with 3 over 14. Is this real or not real? It's real. It's a real number. So these are all limits. So to find the limit, the first step is always substitute. And then you're going to decide, should you stop or you have to do something different. See, this is too easy, right? That's why this will not be in the exam. What will be in the exam comes from? No, because this is too easy. Now, these things will be in the exam. Now, the makeup exam is just based on derivative. All these are for the next exam and final exam. Second case. Why do you have 3? It should be 2. 2. What if you substitute into the function the limiting value and you get 0 over 0? If you get 0 over 0, that means you have to modify the function. Means you have to change the function. How? If it's factorable, go to the factoring and cancel. If it's not factorable, probably you can use rationalization. So rationalize your function. If none of them is possible, and if you're working with trigonometric function, then use trig identities. So you have many choices here what to do. Once you apply all those choices you have, you get a new, completely new function. Now substitute the limiting value again into the new function and get the y value. That's your limit. Example, something like this. So step 1 is always substitute. So let's substitute the limiting value for every x. We have 2 times negative 1 plus 2. We have negative 1 squared plus 3 times negative 1 plus 2. On the numerator, we have negative 2 plus 2. 1 minus 3 plus 2. So what do we have? Negative 2, positive 2 gives us? And then 1 minus 3 plus 2? 0. Oh, we have a situation where we have 0 over 0. That means do something, change your outfit for this function. Give it a new outfit. So what do? We write limit x goes to negative infinity. And first thing we look for is factoring. Is it factorable, both numerator and denominator? How can we factor the numerator? We can factor out 2 and we get x plus 1. How about the denominator? How can we factor the denominator? X plus 2, x plus 1. And then what do you observe? They both have x plus 1, x plus 1. So we cancel them. And what is left? 2 over x plus 2. So it's a completely different function than what we have here. So we are going to do the same step again. Substitute the limiting value into the new function. So what do we get? 2 over negative 1 plus 2. So 2 over 1, which is 2. And now it's a real number. So this is our solution. This is our limit. No, these are the 3 rules we have. I mean for derivative, not derivative, for limit. No, we have few more rules. Yeah, that's true. Not 10 more. 3 more rules. 3 more? 3 more rules. So see, when we substitute at the beginning, that gives us something invalid. So we change our function, and now it gives us something valid. We are happy. Now here's one thing. We canceled something, right? Since we canceled something, so that factor got really angry. And he says, you know what? You canceled me in your function. You know what I'm going to do? I'm going to leave a hole in your function. I cannot let you have a continuous function. So what happens? We get a whole at x plus 1 equals 0. So if x plus 1 is 0, what is x? -1. So it's not a continuous function because that cancel thing leaves us a whole. So it's 1 over. So we have a function like this, -2 here. We have a function like this, and when x is -1, we have a whole there. Okay. That whole has the x value -1. So aren't you curious what would be the y value if x is -1? You're not curious, but you should be, because at the end you have to learn. So we know we have a whole at x equals 1, but at that point, when x is -1, what is our y value? If you know your x, how can you find your y? Where? If you do it in the original equation, you're going to get 0 over 0. You have to substitute into the new equation, because that's a good one. The original one is a bad one. So don't use the original one for the y value. Use the new one to get this y value. Our y is 2 over x plus 2. So we have 2 over -1 plus 2, which is 2 over 1, which is 2. Really? No, I did something wrong. X is -1. -1 plus 2. Oh, the limit and the y value are the same number. Cool. So y value 2 is here. Why it doesn't make sense? I did definitely something wrong. We canceled 1, so x is -1. So we had 2 divided by 2 plus 1 is 2, 2 plus 1 is 3. Okay. X plus 2. So when x is -1, I did something wrong, but I just cannot figure out what did I do wrong. 1 over x, we have 0. So we have a problem here. Then how come it's positive 2? Yeah.
You can do it
No, the first equation I'm going to give you 0 over 0. See, when x is -1, what is y? 0 over 0. And we have a removable discontinuity. Oh, this is a whole, so it's called removable discontinuity. Removable discontinuity. We get the removable discontinuity from the cancelled term. Whatever you cancel, set that equals to 0, solve for x, that's your x value. To get the y value, substitute into the new function and get the y value. So your whole will be at x value -1, y value 2. Yeah. Any question? So we learned few new things. Removable discontinuity, whole, continuous, unremovable discontinuity, and the limit. Yes. So in the exam, in the final exam, they ask, where this function has a removable discontinuity. So what do you have to do? Factor, cancel, set the cancel term equal to 0, solve for x, get the y value. That is where you have a hole in the function. So the picture I drew, something is wrong with the picture, but the concept is correct. Okay. Let's do another example. It looks very similar, but they are not quite safe. Before you factor, first you have to see, do you have a problem or not? If you do, what type of problem you have? That's always the first step. So to figure out whether you have a problem or not, what do? Plug in your limiting value. That should be always the first step.
Always that goes step by step.
Exactly. Because depending on your problem, there is a different types of solution. For example, if you have a headache, you cannot take medicine for your stomach ache, right? Doesn't make sense. If you have a stomach ache, you cannot take a medicine for your broken leg. Like every problem has its own solution. So step one, identify your problem. Based on the problem, you're going to find your solution. So we get 1 square plus 2 times 1 minus 3 divided by 1 minus 1. So 1 plus 2 minus 3 over 1 minus 1. What is our problem? 0 over 0. So for the problem type 0 over 0, what is our solution? Factoring, if possible. So limit x goes to 1. And now factor. How do you factor? X minus, but 2 times 1 is not negative 3. X plus 3, x minus 1. So 3 times 1 is negative 3. And 3 minus 1 is positive 2. Denominator. Good job. It's a difference of perfect squares. When you have 2 terms, there are only two ways you can factor them. You can pull out a GCF if possible. If it's not possible, but you have a difference of perfect squares, then use difference of perfect squares. And then what do you observe? Cancel out the x minus 1. And what is left? X plus 3 over x plus 1. And then you do the same thing again. Is substitute your limiting value into the new function. So 1 plus 3, 1 plus 1. What do you get?
2.
4 over 2, which is 2. That's your limit. The answer for the limit is this. And now they're going to ask you, what is your removable? Where is the removable discontinuity? Removable discontinuity. How do you find removable discontinuity? You set the cancelled term equal to 0 and you solve for x. But you don't only have to find the x, you also need to find y. So when x is 1, what is your y?
That 2 is 5.
This one, it's a limit y value.
So it's
1,
2.
So it's 1 plus 3, 1 plus 1, which is 2. I mean, you can circle here. So we have the answer here is 1, 2. That's the removable discontinuity. And for limit, this is your answer. Your limit is at 2. Irremovable discontinuity means the whole is at 1, 2. Any question? Okay. Now we have a different type. But what is our first step? For any type of limit, what is your first step? Substitute to figure out your issue. So substitute here and here. And you get 4 plus 0 under the radical minus 2 divided by 0. So here's square root of 4 minus 2 over 0. You have 2 minus 2 over 0. So what is our problem? 0 over 0. 0 over 0 means modify your function. Can you use factoring here to modify? So factoring is not possible. So you have to go to a new method. What's the new method? Powering is not possible. Rationalize.
Oh, he told me don't. That's not.
Rationalize. When factoring is not possible, you go to rationalization. So we do limit h goes to 0, 4 plus h minus 2 over h. Do you remember how do you rationalize? So our problem, the only thing that has a issue is the numerator, because numerator cannot have a negative under the radical. Denominator is just one number. It doesn't have any problem. So, to get rid of that radical issue, we need to multiply both numerator and denominator by the conjugate of the numerator. 4 plus h plus 2. So depending on what do you have, you either rationalize the numerator or you rationalize the denominator. Here we are rationalizing the numerator so that the numerator doesn't have any radical. And when you rationalize, the radical term is one term and the other term is another term, second term. Conjugate means you keep your same two terms, just change the sign in the middle. That's called conjugate. So this thing here you see is conjugates, the plus and minus. If you have the same two terms, just their middle signs are different, they are called conjugates. Conjugates. So limit h goes to 0. You have to multiply the conjugate, so you're going to use FOILing method. I mean, you don't have to use FOILing method. Why not? Because when you multiply to conjugates, do you remember what do you get? For example, on the left page, x plus 1, x minus 1, they are two conjugates. Why? Because they're the same x and 1, just their middle signs are different. So if you multiply them, you're supposed to get the denominator. So when you multiply two conjugates, what do you get? Difference of perfect squares. So if you want to have an easy life, all you have to do is take your first component, 4 plus h, take your second component, square them, subtract them. This is what conjugate gives us. Difference of two perfect squares. But if you cannot remember, no problem. Use FOILing method. You're supposed to get the same result. Keep the denominator. Do not do anything on the denominator. 4 plus h plus 2. We applied the conjugate because the radical will cancel out the square. So in the numerator, we're going to have 4 plus h minus 2 squared, which is 4. Again, do not change your denominator. Keep the denominator same. 4 and 4 cancel out. I don't have space, so let me write it here. We have 8 on the numerator, and then h square root of 4 plus h plus 2 on the denominator. And now what do you do? No. We cancel the h. If you plug in 0, you get 0 over 0.
Oh.
You still have the same problem.
Oh.
So you cannot resubstitute until you do complete reduction, complete simplification. So you cancel h and h. That's why you didn't distribute, because your goal is to cancel them. And now you have final products. On the denominator, you have 4 plus h under the radicals, plus 2. On the numerator, you have 1. So let me rewrite this again nicely. we have limit h goes to 0, 1 on the top, 4 plus h under the radical, plus 2 on the bottom. So this initial question turn into this simplified version. So now what do? Plug in 0. So you get 1 over 4 plus 0 under the radical plus 2, which is 1 over 4 under the radical plus 2, which is 1 over 2 plus 2. So what's the answer? 1 over 4. You cancel the h from the numerator. So what is left? You have h and then this.
So the bottom doesn't become human.
Hmm?
Wait, the bottom doesn't become human. To have a one.
So you have this bottom function, which is the entire thing here. Let me write it down. 4 plus h plus 2. So if you cancel the h, on the bottom we have 4 plus h and then plus 2, right? So what do you have on the numerator? 1. Good news, in the final exam, they don't always give this question. Rarely they give this question. Mostly they give this type of question.
Oh, that's easy.
Yeah, mostly. For this scenario.
So there's no hole.
There is no what?
There's no holes for.
There is a hole. What did you cancel? Which variable you canceled? H. So your hole is h equals 0.
Oh. Oh. So the hole is 0, comma 1.
H equals 0, so it will be 0 1/4. So that is second type of scenario, okay? The first type was easy. We didn't have to do anything. In the second type, 0 over 0 means factor, rationalize. And in this class, we are not going to do trigonometry. We are going to trigonometry calculus. That take us to the third scenario.
Wait, that's 3 already.
This is 3.
That's supposed to be 4.
No. The first one is substitute stuff. The second one is substitute 0 over 0 means modify. Yeah, but this is one scenario. It's 0 over 0. So same problem, 0 over 0, 2 types of solutions. And now this is third type of scenario. When you substitute, you get a number on the top that is not 0, but you get 0 on the bottom. Still, it's undefined. But it's different types of undefined. In this problem, we have something like this. Our graph completely breaks down into 2 pieces. So we get unremovable discontinuity, which there is no way we can make them continuous. And at the point where the graph completely breaks down, observe, either they are going upward forever or they are going downward forever. So when you have a vertical, this type of scenario is called vertical asymptote. Okay? B over 0 means vertical asymptote. So vertical asymptote, you don't get a number as your limit. Because observe the y value. When you are going towards 0 from the right side, your y value is going toward where? Infinity. And if you are going the axis towards, you are going to the axis 0 from the left side, the y value is going toward where? Negative infinity. So you don't get a number for your y, you get either positive infinity or you get negative infinity. So what we're supposed to do is, we are going to pick a number very close to the limiting value and observe its sign. If the sign is positive, it means it's positive infinity. When you pick a number from the left side and you get a number negative, it means the answer is negative infinity. So if you get two different signs, then exactly at that point, the limit doesn't exist.
It's any not, like any number.
Any non-zero number,
What number?
any non-zero number on the top means it cannot be zero.
Oh,
Anything that is not zero. Could be fraction, could be whole number, could be decimal, could be anything, but that cannot be zero. If you have any non-zero number on the top, but is zero on the bottom, that's the vertical asymptote. So either the limit doesn't exist or the limit does exist. If you have this type of scenario, and if you're walking toward from the right side, your y is getting toward positive infinity. If you walk from your left side, your y is still going positive infinity. So if the left and right gives you the same sign, your limit exists and your limit is that sign with infinity. So here is positive, here is positive. So limit is positive infinity. And how do you find that? We pick a number very close to the limiting value and you observe the sign. You cannot take anything more than 1 unit. You have to be very close. Otherwise, you get different answer. Completely wrong. Okay? So our problem, vertical asymptote, solution, pick 2 points, one from the left side and one from the right side of the vertical asymptote, and then see their sign. What type of scenario we have? Before the scenario, more steps. So how do you start? If it's factorable, factor and cancel. Okay? If it's factorable. Once you factor and cancel, you're left with the denominator. And then your vertical asymptote comes from the denominator. If the denominator is 0 after cancellation, then it's a vertical asymptote. So what you have to do, pick a number, blah, 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 and then do that. So if you are walking from the left side and right side, and you get the same number, then the limit exists. So the exact limit at that point, at that limiting value, will be the same positive infinity or negative infinity, depending on the number you got from your left and the right. But if the left side limit and right side limit give you two different signs, then the exact limit doesn't exist. So exact limit means it doesn't have any superscript. Positive, negative doesn't have anything. It's just the number itself. Exact limit we determine only by observing the left limit and the right limit for vertical asymptote. We didn't have to do that for the first scenario or the second scenario. So here our problem is vertical asymptote, solution, left limit, right limit. Yeah. For example, we have 7 minus 2x divided by x minus 5, and we want to see what is our limit when you walk to 5 on the x-axis. So step 1, substitute and see your problem. What type of problem you have? So 7 minus 2 times 5 divided by 5 minus 5. Denominator is 0. What do you get at the numerator? Negative 3. So it's not 0 over 0. It's a number over 0 that tells us we have a vertical asymptote issue. So for a vertical asymptote issue, our problem is left side and right side. So our solution is left and right. But before we do left and right, can you simplify this? Is it possible to simplify?
No.
No. That means we go to the left and right directly. We pick a number very close to 5 on the left side. So let's look at the number line. We have 5 here, 4 here, and 6 here. On this side, what is the very closest number to your 5? It cannot take more than half unit. So 4.9, very close. Any substitutes here. Your y value is 7 minus 2 times 4.9 divided by 4.9 minus 5. So 4.9 minus 5, what type of sign you have? Negative. And now on the numerator, we have 7 minus 4 times 2, 4 times 9 is 18. 4 times 2 is 8 and 9. 7 minus 9.8. So you have negative over negative. What's the result? Positive, right? So the left side limit is telling us our answer is positive infinity. We only care about the sign, okay? The number doesn't matter, the sign. The numerator is negative, denominator is negative, so the result is positive. So the left side limit is positive infinity. Now we go to the right side and we do the same thing. Pick a number very close to the 5, but on the right side. What number we have? 5.1. So we do y is 7 minus 2 times 5.1 divided by 5.1 minus 5. The numerator is positive, right? 5.1 is bigger. But how about so denominator is positive. How about the numerator? 7 times 10.2. It's negative over positive. What is negative over positive? Negative. So our right side limit is telling us it's negative infinity. So what's the conclusion for the exact limit? Limit exactly at 5 of this function. Undefined, doesn't exist. Does not exist.
Last before we go.
No, we need 3 rules to remember. To remember for one more limit problem.
That's big.
Right. So for these cases, we have numbers, right? Either number or infinity. So if you observe, all these limits are going toward a number. So we have one more rule that is about limit when going to the infinity. And that's when we're going to remember the 3 rules. So that's all about main concept, okay? The limit. And remember, 2 is there. I didn't tell you the first number. 2 is there. 2 is there. You're going to go, why should I write it? Here. 9, 1:30 and 12:30 p.m. This building, one flight down, room 9, 1:30 at 12:30, okay? From 12:30 to 1:45. And study the exam very well. I'm going to post the solution after Saturday. 9, 1:30 at 12:30. All I have to do is study the exam very well. I'm going to
Can you give like local for this question?
we will see.
All right. Good day.
Should you?